help.
Heaven is close now. Time for me to go. Heaven is close now. I am coming home.
And then we are going to answer number 1. August 2016. It says the average blade velocity. What are we given already?
Average blade.
It's you. Are we together? The average blade velocity of a single stage impulse turbine is 300 meters per second, right? 300 meters per second. The relative inlet velocity of the gas is 600 meters per second, right? Relative inlet velocity of the gas. That's relative inlet velocity of the gas is, yes, that is correct. 600 meters per second. The blade inlet angle is 20 degrees, right? The blade inlet angle. Remember, they say the blade inlet angle, not the nozzle or the gas. So the blade inlet angle is? That is absolutely correct. So theta, no, let me write theta in a nice, in a theta-ish way. Yeah?
That's not theta.
Yes. Which is 20 degrees. Friction causes a 5% loss in velocity. Now, if friction causes a 5% loss in velocity, what is the coefficient of friction? 95. That is absolutely correct. 95%. So it's 0.95. Are we together? As the steam moves over the blades, the turbine does not develop any axial thrust and it uses 90 kilograms of gas every minute, right? So the mass is 90 kgs per minute. Now, use the scale. Now, normally they give you a scale, but I just pray that they don't give you a scale. I think the question that I'll give you, I will remove the scale, right? That you guys can practice making a scale. Use a scale of 1 centimeter is equals to 1 centimeter is equals to 50 meters per second. And construct the velocity diagram in the answer book. Enter all values into the diagram. No marks will be given if the values are not entered onto the diagram and if the diagram is not constructed to the given scale. You need to use the other page. Now, in landscape format. So I need you to always use this in landscape format because they'll always want you to use this in landscape format. Are we together? Thank you. Okay, so let's answer this question together, right? Now, let us start. What is you start with a straight line, right? Are we together? But your straight line, don't make it too big. Don't let it go way up high. Just let it sit slightly up here, so that you get more room to work up here on top. Are we together, right? Now, normally other people start with you, but in this case, we're not going to start with you. Are we together? Right? We're going to start with VRI. We're going to start with VRI. So let's start. Right? We are given VRI, which is 600 meters per second, right? Mm-hmm. Hey, my guy. These are the things that I forget to teach.
En la jugada, momento PDF.
50.
12.
We did this yesterday though, right? Let's move on. So, now, we are going to start with VRI. Are we together? Now, let's convert VRI into meters per second, right? Into centimeters. 600 divided by 50, what do you get? With no calculators. Just say 6 times 2, 12. The answer is 12, right? Right? Yes, the answer is 12, right? So, I need you to put 12 centimeters on your ruler, right? And then put 20 degrees there, right? Put 20 centimeters on your ruler and put 20 degrees so that your thing does not exceed the textbook, right? It does not exceed your answer book. That's the most important thing. We don't want a diagram that is going to be bigger than the answer sheet. So you must always make sure that it's not bigger than the answer sheet, right? So put it on 20 degrees and then put it on 12 centimeters. So if it ends here, that is perfect. Are we together? Right? Or slightly here, that's perfect. So you there, right? It's 20. You there, right?
How many centimeters?
It's 12 centimeters. You there? Another thing, Michelle, I see. I think you're making a mistake. Right. Another thing is don't start here as well, right? Because if you start here, don't forget. We are going to put our U that's going to go this side.
Okay.
And then the other one will have to go the other side as well. So make sure that it's on this side. You say? Put it close to the end, close to the edge.
12 centimeters.
Yeah. Let's see yours. Where is your 12?
Where is it?
Can you move it back just slightly a little bit?
A little bit hard. Like that's right.
So mine is going to be like this.
The top to her, she doesn't want.
Michelle,
Why?
the guy is borrowing the rubber. For he wants it for wrapping.
Why did he make a mistake? Why?
20 degrees, right? Then this is VRI. Now, what I need you to do is I need you to put this doesn't look like 20 degrees, right? Let me put proper 20 degrees here. I can do degrees with my hand, approximate degrees. 20 degrees looks something around like this. So 20 degrees. VRI is equals to 6 centimeters.
6.
Theta is equals to 20 degrees. Are we together?
Why is Parisama?
Right, yeah?
Why is Parisama?
What do you mean?
6 centimeters.
12 centimeters, sorry, 12 centimeters. I don't know where the 6 came from. Because the 6 divided by 50 is 12 centimeters, right? 12 centimeters, right? We there. Now, this point, now that's your B. Are we together? Right. Now, let us put our U. Say 300 divided. Oh, my mind was already here. Sorry. My mind was already here. Now say 300 divided by 50. What do you guys get? 6, right? Now, from B, measure 6 centimeters going back. Are we together? Now, from B, measure 6 centimeters going backwards. And put a, so U is equals to 6 centimeters, right? And this is our C point. This is C. Are we together, right? That's C. Now, I need you to join a line from A all the way up to C. Are we together? I need you to join a line from A all the way up to C. Now, can you measure this angle for me? If you can you measure this angle for me? And what do you get your alpha as? Let me give you a few seconds to enjoy this question, right? Now, if I hear anyone saying power machines is difficult, I'll be disappointed. Because this is like 23 marks. When you go in the final exam, right? That's your 23 marks, and it's guaranteed. So, yeah, that's awesome.
Degrees.
14
degrees.
14. Michelle, what did you get?
Which one?
Alpha. Or your inlet angle for the gas. 14. You got? 14. All of you got the same answer. Now I'm suspicious.
Just copying me.
Okay. Now, you guys, I'm writing mistakes. It's VRI. Now, can you measure for me from A all the way up to C, or can you measure for me our inlet velocity of the gas? 17,7. What did you get?
From B to C.
From A to C. Now, I need both, so that I can see who's making mistakes.
About 17,1, 2, 3.
17,7 centimeters, right?
Yeah, 8 actually.
8. Rounding off, this is going to be 17,7. Okay, let's move on to the next part, right? Now, they say that the coefficient of friction is 0.95. Are we together, right? The coefficient of friction is 0.95. Now, we know that VRO. I was confused between 2 and O. I wrote I. So VRO is equals to coefficient of friction VRI. Are we together, right? Now, we're given our VRI as 12 centimeters, or you can say 600 meters per second. Are we together, right? So it's going to be 0.95 multiplied by, let's multiply by 12, shall we? So that we'll get the answer in centimeters. It's still going to be the exact same thing. 0.95 multiplied by 12, what do you get? 11,4, that is correct. You know, I would have done this with my head, you know that, right?
I know.
11,4 centimeters. Thank you. 11,4 centimeters. Now we've got VRO. Are we together, right? We've got VRO, but we don't have the angle for VRO. Are we together? Right? We don't have the angle for VRO. Now let's move on, right? This question told us that there is no axial thrust that was developed. Are we together? Right? Now, the formula for axial thrust is this one. Now, if no axial thrust is developed, that means it's going to be 0 is equals to m VFI minus VF2. Are we together? Or VFO, depending, right? Now, if you do your mathematics, right? Now, don't be scared. Don't be scared. Don't worry.
Good.
If you do your mathematics, divide both sides by m, both sides by m, you'll be left to 0 is equals to VFI is equals to, minus VFO. If you do your mathematics, VFI is equals to VFO. Are we together? Does this make sense? Okay. It's coming along, right? Okay. Now from C, yes, to this center line, can you measure it for me? What do you get?
From what?
From C, moving all the way up to the center line. Can you draw for me a straight line and measure it for me? 4,2. That sounds too small. What did you get? I think both of you are going to get the same answer anyways, right? But I doubt Prince will get the same answer.
The angle now is small.
Yeah, the angle is 20. That makes sense.
4,2.
4,2. So, we know that VFI is equals to 4,2. Are we together, right? Let me write it properly. 4,2. That means that VFO is also equals to 4,2. Are we together? Now, what you're going to do is, I need you to take your ruler, right? Ooh. Yes, I'm going to need you to take a ruler. And then from B, don't draw anything yet. Don't write anything yet. Are we together? I will need you to have 2 rulers though. How many rulers do you have? 1. You can also use the protractor. I think it will work, right? So, as long as you can draw straight lines with it. Same as you. You've got 1 ruler as well, right? Okay. So, I'm going to need you to, on your ruler, right? I need you to mark 11,4 centimeters on your ruler. Right? After you mark 11,4 centimeters, put it on B, right? Put it on B. So where your 11,4 centimeters stop, that's where your ruler, that's where you should stop. Are we together? But don't write anything yet, since we don't have an angle. Are we together? And then after that, I need you to put another ruler here. Are we together? And then your ruler should make sure that it makes a right angle here. That's the most important part. That your ruler makes a right angle here, right?
So anywhere randomly, we just put a 90 degrees.
Not anywhere randomly, because they should intercept, right? And you're going to need 2 rulers here. Michelle, can you take out another of your ruler and borrow it to your good friend over there? Right? Don't draw anything yet. Don't draw anything. Hey, Michelle.
I'm trying to make it easier for myself.
No, it's because you don't have the angle yet, right? So you don't know which angle are you going to use, right? So I need you to have 2 rulers. The other ruler should have been measured, what's the centimeters? 4,2 centimeters. And the other ruler should be measured 11,4 centimeters. So where your 11,4 centimeters intercepts with your 4,2 centimeters, right? I need you to put a dot there, right? Where those 2 intercept. But make sure that on top here is 90 degrees. Are we together?
What's the length of that one that's perpendicular?
This one?
Yeah.
It's 4,2.
The perpendicular one is 4,2.
4,2 exactly, right? So you should have a 4,2, and then where the 4,2 ends, it should also intercept with your 11,4. Are we together? That's the most important part. Is where the 11,2 ends, it should intercept with the 4,2. So this line should be 4,2, and that line should be 11,4. And where those 2 intercept, that's where you're going to put your thing. That's where you're going to put your dot, and then you draw your lines there. Are we together? Did that work? I need to double check. Can I? So for me, my 4,2 is somewhere there. Are we together, right?
That's fair.
Hey, me, I'm blessed. I'm blessed. I can take shortcuts. God loves me, right? I don't know about you guys, but God loves me. That's 4,2 centimeters. Then this is VF2 or VFO, depending, right? It depends. No, I'm not going to hold a gun and say use 2 or 1. Right? And then this one is going to be 11,4. VRO is equals to 11,4. Can you measure this angle for me?
Which one?
The inside angle. You said there is theta, the other one is what? It's
It's
20. Yes. This is my fault. I forgot to tell you. If the axial thrust, if there is no axial thrust, right, the blade inlet angle is equal to the blade outlet angle. So yes, all your answers are correct, right? I forgot to mention that. Hey, that has slipped my mind. That has slipped my mind. What's the name of this angle? The blade outlet angle. What's the name? Prince, you said that angle is called what?
What's the sign? It's a 5.
Fine. Okay, now this is our D point. Are we together, right? Now, can you draw a straight line from A going all the way up to D, right? And when you're done, can you measure this angle for me, right? And can you also tell me what is, can you measure that angle for me? What do you get for your angle?
So we first have to draw the line.
Oh, yes. From D all the way up to A.
Which angle do you want to talk about?
This one, the last one. Now it's very, very important that you write everything onto your diagram, right? This is where the marks are. The angle is 6,2.
No,
The length is 6,2. Prince, what did you get for the length?
6,4.
So yeah, both of you are correct. So I'm going to put 6,3, right?
Yeah.
And then what did you get for beta? Beta. What did you guys get? If your angles are different, then both of you got the wrong answers. Yes? 43.
Yes.
43 degrees. We're done with the diagram. Eh? We're done with the diagram. Now let's answer the questions.
Wait, before you answer. Okay, I want to know, in that 5 meters, how did it turn into that 12 centimeters? You divided
By the scale, yeah. You divide by the scale.
Okay.
Yeah. That's the most important part, is you divide everything by the scale.
Okay, so 300 by 50, 600 by 50.
Yeah.
That's-
I think those are the only things that happen. Okay, let's answer this first question, right? Okay, so number 1.2.1. Calculate the exit gas angle leaving the turbine. Calculate the exit gas angle leaving the turbine. Which angle are we looking at? Calculate determine the angle, the exit gas angle leaving the turbine, right? The exit gas angle leaving the turbine. Oh, by the way, that's our B, right? Our beta. So our beta is equals to 43 degrees. Beta. Nice. Next question. Calculate beta.
Yes.
Hey, I'm going to get Jesus on that one. 1.2.2. Next one says calculate the inlet gas angle. Calculate the inlet gas angle. Which one are we looking at? We're looking at this one. Are we together? Right?
Which one?
Our alpha there. Right. So alpha is equals to 14. Let's do 14 degrees. Let's do the next question, 1.2.3.
What is alpha?
Alpha is 14.
Yes, what is it?
What is it? It's the inlet angle of the gas. Or you can say it's the nozzle angle as well. It's one and the same thing. Next one, calculate the exit blade angle, right? Calculate the exit blade angle. What is our exit blade angle? Yeah, for the exit blade angle, we don't really have to stress too much. Since there is no axial thrust developed, so the angle is exactly the same. Are we together? Right? So that means you say it is phi, eh? Yes, our phi is 20 degrees. Phi. He said it's phi. Hey, I'm just following him. If anything is wrong, you can talk to him.
I think it's a 5 in Greek.
Phi in Greek. I should go and research that.
Greek
Yeah,
lessons.
it's correct.
It's correct.
Yeah, but don't put the bars on top.
The bars on top.
And
It's electrical engineering that's killing me. Alright, let's do the next one, right? The next one says calculate the power developed. Are we together? Now, what formula do you use to calculate your power? Mass multiplied by?
Power. Volume.
Let's move on.
What? Wait, so which formula is that?
The one that I gave you yesterday. The formula for calculating power is mass multiplied by the total wheel velocity multiplied by u. Oh, the one that I gave you started with u instead of w.
Started with M, U,
Then w. VW, not WV.
You said VW. Volkswagen.
This looks wrong.
It's M, U.
I'm going to go with my first one. But as long as you know what it means, it stands for wheel velocity. Right? It stands for our wheel velocity. Okay, so our mass was given as 90 kgs, are we together? But it's power, right? If it's power, do we use 90 kgs a minute or 90 kgs an hour or 90 kgs a day? What do we use?
Isn't it per second?
Per second, that is correct, right? What's 90 divided by 60? No calculators involved.
1.5.
No, 1,5.
1.5.
Yes, 1,5. Because 60, 90 minus 60 is 30. Half of 60 is 30, right? Multiply by. We did not calculate the wheel velocity, right? So, can you guys raise this up for me? And can you guys raise this up for me? And can you measure the total distance between the two? What do you guys get? Let me multiply by you while I'm waiting for you.
28. 20. I mean, 21.
Prince, you don't sound so sure. 21. You're using a 20 centimeter rule. So we shall is 21,8. But 21,8 centimeters, right? And we need it in meters per second. So we multiply by 50. Are we together? And what do we get our answer as? And this one I can do.
90,000.
190,000?
490.
490. 500. That's in watts. Are we together, right? Your answer will be given to in watts. So this answer is too big. So we convert it to kilowatts. Are we together? Kilowatts we divide by 1,000. So 490,5 kW. Are we together?
I'm 10 to the power.
Make positive 3. Alright, let's do the last one, right? Did I give you the formula for diagram efficiency? So the formula for diagram efficiency, you are going to use, give me 2 seconds. Diagram efficiency, you guys are going to use diagram efficiency is 2u VW over VI squared. That's our formula. Are we together? So it's going to be 2 multiplied by
9.8. What is that? Is it U?
Yeah, it's U. U is 300. Yes. I have forgotten what 300 is. Multiply by 300. Multiply by VW where we got 21,8, right? Multiply by 21,8, multiply by 50. Everything is divided by VI. So for VI we got 17,7. So open bracket 17,7 multiplied by 50 squared. Are we together? Multiply by 50 for our centimeters to meters per second squared. Ooh, this one will die. Hey, I'm still too young. I want to get married. I want to have babies. I don't want my head to explode. This one is too difficult.
0.385.
85. Oh, by the way, it's efficiency, right? It's efficiency. Why do I keep on forgetting to multiply by 100? It's efficiency, right? So if you multiply by 100, what do you get? You're going to be 38.5%. Are we together?
Say, 0.83.
Or 0.835. Okay. Hey, I'm getting older. You guys will have to forgive me. 835. So it will be 83. Now I'm making a mess now. My teachers in primary used to beat me for making a mess. 83.5%. There was this lady, she didn't like us to cancel. So I'll use a rubber.
So what did you get the 300 from me?
300 from you, it's you.
Me.
Hmm?
You get it.
You is our lead.
You, not me. Okay.
Not?
Me.
It's not
I don't know you.
mu is the other one. It's the
Yeah.
it's the
Mu is that,
0.95.
Greek letter.
Oh, this one.
Yeah, it's me.
Mu. I just call it the coefficient. Or sometimes they call it the micro. Macro coefficient. That's one.
Come home, come home, come home, come home.
She left the house in the morning, supposed to go to school, but now it's 8 p.m. and she ain't nowhere in the mama's view. Staring in the rear view, riding with some random dudes.